Welcome to MRU E-Learning powered by Mallarity University. This is Dr. J. Pradeep Kumar, Associate Professor and in charge of First BTech AML, Freshman Engineering Department. Okay, today we are discussing about one of the important topic in the data structures called single linked list. Now let us, before going through the single linked list directly, let us go through the first, what is the roadmap of my presentation today. So if you observe, we are going with the data structure fundamentals in brief, and the linked list introduction part and the single linked list, the operations on the single linked list, and finally we conclude the session with the comparison of arrays and the linked list. So when we go with the data structures, irrespective of any discipline, whether it may be a computer science or any other branch, data plays a very prominent role. So we need to store the data in a manner where we can easily perform the operations. So one data structure may not be suitable for all. So choosing of the data structure plays a very prominent role in any particular experiment or any operation. So when we go with the data structure specifies a logical arrangement of a data. So why we say that it is a logical means definitely there is a relationship exists between the elements of a data structure. So the arrangement plays a prominent role in anything. So when we perform the operations like traversing, insertion, deletion or any other operation, the way in which we arrange the data plays a prominent role. Now just in brief, when we go for the classification of the data structures, you can observe there are basically we divide the data structures into two categories. One is a primitive and another is a non-primitive. So primitive data structures are being supported by any programming language basically. So we don't need to define any operations on that automatically. And the non-primitive data structures are the user-defined data structures where the user has to explicitly define all the entire data structure, the operations and everything. So when we go with the non-primitive, there are again two categories. If the data is arranged in a linear fashion, we call it as a linear data structure. If the data is in a hierarchical manner or any other so we refer it to as a non-linear. So here, we are concentrating on the representation of the data. So I'm going for how we can represent the data. So when we want to represent the data, there are two fundamental approaches are being available. One is array representation and the linked list representation. I think array representation are being familiar for everyone where we are storing the data in a homogeneous elements and where the elements are accessed by using an index. Okay, now we go with the linked list representation. So the major difference between the both is the memory allocation, where an array is a static memory allocation and whereas a linked list is a dynamic memory allocation. Still, we go with the major differences between the array and the linked list at the end of this session. So we start with the linked list. So when we go with the linked list, what is a linked list? A linked list is a fundamental data structure composed of nodes created using a self-referential structures. So why it is called as a self-referential structures? If you consider a linked list representation, a node is pointing to the another node itself. That is, it is called as a self-referencing. We are representing the node pointing to the next node in the linked list representation. So we will go into the depth of the linked list. So first we will start with the properties of the linked list. So when we go with the properties of the linked list, first it is a non-continuous memory allocations. So unlike to the arrays, so we no need to store the arrays in a continuous elements in a nodes in a continuous fashion. So the nodes can be anywhere and it is a dynamic size. It can get grown or shrink at any time. If we want to create a node, we can create then and there itself. If I want to remove or deallocate the memory allocation allocated for a node, I can do that. Then access via traversal. So we can say this is one of the major drawback of a linked list. Why? Because if I want to access 10th node, I should again start from the node 1. Okay, because the representation, the traversing always should start with the first node. And definitely it requires a pointers. So in some languages it is called as a reference or anything. So we require a pointer or a reference for accessing the nodes of the linked list. Next. So we start with the first, a basic, that is the types of the linked list. How many types of the linked list are there? So there are many types of the linked list are there. I mentioned a few of them. So first is the foremost one, the topic which we are been discussing today, that is a single linked list, where we have each node has only the two parts, the data part and the pointer part, where the pointer will point to the next node of the linked list. Next, when we go for a single linked list, we can traverse only in one direction. So it is a unidirectional. But when we go for a double linked list, it is a bidirectional where each node consists of the three parts: data part, next, and the previous. So the next will pointing to the next node, whereas the previous will point to the previous node of the list. So double linked list is a bidirectional. We can traverse in both directions, either in the forward direction or in the backward direction. Next, we have one more type of that is a circular linked list, where the last node will be pointing to the first node, making a form of a circle. This is called as a circular linked list, and is a combination of a circular linked list and double linked list. We have a circular doubly linked list. So where it has both directions of traversing, as well as the last node will be pointing to the first node. And we have one more one which is called as a header linked list. So it contains a one special header node which doesn't hold any data, but it is generally used to make the operations to be simpler. So today my topic is completely concentrates on single linked list. So let us see the single linked list structure. So you can see that each node consists of two parts. One is the data part and another is the next part. So the data part will be pointing to contains the actual value, whereas the next part will contains the reference to the next node. Now if you observe carefully, the address of the nodes are being different, which shows that it is a non-continuous memory allocations. Now here the start, here that start can be named as head, or any other names can be given in different textbooks. We have a different naming terminology that can be used for the first one, but here I named it as a start, which will point to the first node of the linked list. So if you observe that, so the start plays a very prominent role, because as it holds the address of the first node. If the start value becomes null, or if we remove the start, the entire information about the linked list will be lost. So this point to be remembered for that. Then, so as we already discussed about the node structure, and if you observe the last node contains null value as the next. So here the next will contain the address of the next node, as we have discussed already. But if I consider for the last node, it contains a value called as null. It means that it will be the last node of the linked list. So since it is a single linked list, I can only forward, I can move only in the forward direction. That is, I can move from the first node to the last node. At any point, I cannot move back. Then, so we go with the operations on the single linked list. So here I identified, so we have a many number of operations. We have just gone through some basic operations, starting with the isEmpty, traversing, find, search, inserting, and deleting. So we first start with isEmpty. So whether we want to know whether the linked list, single linked list contains any nodes or not. So this can be done by using isEmpty, which we call it as, which is used to find the link, whether the status of the linked list. So a very one simple condition we need to check whether the linked list consists of the nodes or not. So if you observe the linked list here, if the start value is null, we conclude that the single linked list is empty. Otherwise, the single linked list is not empty. So one simple condition will be able to identify whether the linked list is empty or not. Then we start with the next one, that is a traversing. So we call it as a traversing or anything. So traversing generally refers to accessing elements of the link, any data structure at least once is called as a traversing. So we need to traverse all the elements of a given data structure. Now if I want to traverse the single linked list, I should start from the start and I have to reach to the last node. That means I have to reach to the node where the next part will contain a value called as null. So what we do? So we already discussed that the start value should never be changed. For that purpose, I am initializing the start value to a temp. Now if I check, if we say that if the temp value is equal to null, as we seen before, that is isEmpty method. So temp equal to null, that means the linked list is empty. If not, what I need to do? So I am using a while loop to move the pointer from the first node to the last. So what is the condition I am using? While temp not equal to null. So until the temp value not equal to null, I am performing the instruction. So what I am doing? First, I am displaying the temp of data. So if you observe that the initial value of the temp is equal to start, which here it is equivalent to 4800. So 4800 data part, the value 10 will be printed. Then if you do that, then move to the next node. How I am moving? temp equal to temp of next. So what do you mean by that? Now the updated value of the temp will be 4900. So because 4800 next part is 4900. So the updated value of the temp is 4900. Now when I print, since the condition is true, temp value is not equal to null, it will displace the temp data which the value is 15. So similarly, when I move that, the next updated value will be 5000. So and 5000 the condition is true, and when I print the data, the value printed is 10. Then when I update again the temp value, it becomes 3000. Then the condition is true and it displays the temp data which is the value equal to 20. But again, when I move to the next link, the value becomes null. So when the condition, when the temp value becomes null, we stop the process and we see that all the values of all the node values of the single linked list have been displayed. So this is a very simple operation where we perform accessing of all the nodes of the single linked list. Next, find. So what do you mean by a find operation? Now we want to find what is the value present at a particular position. That we call it as a find. Now assume that here I want to find what is the value present in the third position. So let us assume that the position is a 3. Now what I am doing? Similarly, I am initializing the temp value to the start. Then similar. So we need to check whether the temp value is null, it is a linked list is empty. Now in order to monitor the position, I am taking a variable called k which is initialized to 1. Now if you see the live, so I am using the while loop in order to make the pointer to move to the required position. Since we want to display the third position, I am using a while loop, okay, which consists of the conditions, so both the conditions, temp not equal to null and k less than position. So these two conditions are used to make the pointer to move to the current position. So I am just moving the temp pointer similar to the last traversing operation, and every time I am incrementing the k value also. So initially the first k value will be 1. So since it is less than 3, it will enters. Next time k plus k becomes a 2. 2 is less than 3, again it is a true. So again it will enters. Then once the k value is less than 3, 3 less than 3 becomes false. And if you observe that the temp value will be 5000. So initially it will be 4800. So it will be iterating for 3 times. So initially it will be 4800, then it will be 4900, and then it will get the exact address what we want, that is a 5000. So here we will print the temp data finally. But there is another case we need to consider. For example, here in the given single linked list we have 4 nodes. But assume that I want to find the 6th value or 6th position value. But if you observe that there are only 4 nodes, and if you are giving a 6th position value, it means that it is an invalid position. How can you find that is, if I am moving the temp value, finally the temp value becomes null, it means that the position what you have been given is an invalid position. Okay, so this is the find operation. Next, we go with the search. What is a search? So it is exactly opposite to the find. I am giving a value. Now I want to find the position of the value present in the given single linked list. So assume that I want to search the value 20 in the given single linked list. So here also the same procedure what we have done. Temp is initialized with the start. I am checking for the condition for the linked list whether it is empty or not. Next, now I am taking 2 variables. One is a flag which is initialized to 0 to make the confirmation whether the element what I am searching is found or not. If not found, the flag value will be 0 as it is, or otherwise the flag value becomes 1. Now let us go through the logic. So initially I have taken, okay, I am using a while loop. So temp not equal to null and flag not equal to 1. So these are the 2 conditions what I am using to search the value. So if you search, so first the temp value will be 4800. So now 4800 data. So the value you can see that it is a value 10. So the searching value is 20. So the condition is not equal. So temp equal to temp next. So it will move to the next value, that is 4900. So 4900 data part. What is the 4900 data part? 15. Again, 15 is not equal to 20. Again, it will move to the next, that is the temp not equal to, okay, say put temp equal to next, that is a 5000. Now 5000's data part is 5. Again, the condition is false. So again, temp equal to temp of next. So that is finally the temp value becomes a 3000. So 3000 data part is 20 and the value is 20. So if you observe, the condition becomes 2 and the position becomes 4 and the flag value becomes 1. So automatically the condition, so I'm using a break, automatically we are coming out of the while loop. So if the flag equal to 1, we conclude that the value 20 is present in the position, otherwise the value is not present in the single linked list. So in this manner we will perform the search operation. Okay, now we are going into the very important operations. One is a insert and another is a delete. So these plays a very prominent role in case of a single linked list. Now when we go for the insert operations, we consider the 3 strategic approaches, or I can say the 3 different positions where I can perform the insertion. First, one is the beginning position, number 2 the end, and number 3 at the required position other than the beginning and the end. So these are the 3 cases we need to consider for the inserting of a node. Now we start with the inserting a node at the beginning of a list. Now see this. So we already discussed that linked list is dynamic. It has a dynamic memory allocation. We can grow or we can shrink the number of nodes at whenever we require. Now, so we already have a single linked list consisting of 4 nodes that you can observe it. Now I want to insert a node. I name it as a new node. If you see the first point in the algorithm, create a new node and allocate a memory, because we are allocating the memory dynamically. Whenever we want a node, we create a node, we will allocate the memory node for a node then and there itself. Now, if you observe that I am inserting a value, whichever the value I want to insert. So let us say I have already specified that I want to insert a value 8 at the beginning of the linked list. So I placed 8 in the data part. So new node of data equal to 8 and I kept new node of next equal to null. So this is the basic structure what I have done for the new node. So I named it as a new node where the data part is the value which I want to insert and the link part, that is the next part, contains null value. Now I want to insert the node at the beginning of the list. Now what I have done? If start equal to null. So we already seen that if start equal to null, it specifies that it is the linked list is empty. If it is empty, then it becomes the start node. So I will simply say that start equal to new node. If start value is not equal to null, that means linked list contains already the nodes which we are seeing. Okay, now if you observe that here, if I want to make this node as a start node, I have to perform 2 things. The thing is that I have to make the new node to point to the first node and the start should point to the new node. Among these 2, which we need to be done first? This is the important thing what I need to do. Why? Because, for example, if I make the start will point to the new node first, then we lost the value 4800. So this is a cautious point what we need to do. So we need to perform 2 tasks, but the first task what I need to do is I should not lose the address of the node, first node present in the start. So what I have done, if you observe that, new node of next equal to start. So automatically, if you observe that, before it was the value is null, now the new value is 4800. So the new node is pointing to the start node. One task done. The second task, the start should point to the new node. So start equal to new node. So automatically the start value, it is 4800. Now the new value is 6500, which is pointing to the thing. So in this way, we will insert a new node at the beginning of the list. Then go to the end. So the second case, inserting a node at the end of the list. So this is another case what we need to do. Now I want to insert a value 35. The same thing, I have allocated created a new node and allocated a memory. The data part has been inserted a value 35 and the new node link part is null. So this is the thing what we need to do. You want to insert this node at the last of the single linked list. Okay, initially I will check the same condition. If the start equal to null, then the linked list is empty. I will make the start equal to new node. Now consider the second case. That is when the linked list contains the node. If you observe, okay, the node, the same scenario what we can observe here, there are 4 nodes are there. I want to insert the node to the end. So here we have seen the basic point that whenever you want to traverse, you should start from the first node. So here my task is to move to the last node and then I have to insert the node at the end. So for that purpose, I am initializing the start value to a temp because I should never move the start value. Then while temp not equal to null, not equal to null. So what is this? So when temp of next not equal to null, what it does? It will makes to reach to the last node, that is the temp value will stop at the position 3000. So this is the target what we need to reach. Why? Because if the temp value finally becomes null, I cannot do nothing. So my target here is I want to make the temp to reach to 3000. That is, initially it was 4800. I will be going on moving and finally I will reach to the value 3000. So in order for that, I am using a condition temp of next not equal to null and I am moving. So if you observe that, so initially the temp value will be 4800, then 4800 next part, 4900 it is not equal to null, condition is true, temp equal to temp next. So the new value is 4900, then 4900 next part is 5000, it is also not equal to null. So the condition is true, it will move to the next, temp equal to temp next, which is equal to 5000. Okay, now when temp of next 5000 next part is 3000, it is not equal to null, then again temp equal to temp next, and so automatically the new value of the temp is 3000. Now when you check this condition 3000 next part, it is a null. So if you observe that 3000 text next part is null, so the condition becomes false, and if you observe that the temp value is 3000. Now the only task what we need to do is we want to insert our new node to the end of the list. So a simple thing, temp of next, that is 3000 next part, that is the reference part should contain the new node. The address of the new node is 7000. So when I say temp of next equal to new node, so the null value is replaced with the 7000. Automatically a reference has been established to the last node, to the node, new node which we have done. So our task of inserting a node at the end of the list has been done. Yeah. Now one interesting scenario. Now inserting a node at a particular position of the linked list. Now, so we have seen the beginning and end. Now you want to insert a node in the middle of the list. Not only the middle, any position. Now let me check. So here I want to insert a value 25 at the position 3. So value is a 25 and the position is a 3. Now what we will do? So first we will create a new node and allocate the memory. So new node of data equal to 25 and null. So here you can see the structure I have done with that. The data part contains the value 25 and then the next part contains the value null, and the new node address is 6300. Okay. Now here I want to insert at the third position. When I want to insert the value at the third position, so please be that we have to move to the second position. That is, now here in order to perform that, we need to stop at the address 4900. So that is, we need to move to the second node. We cannot move to the third node. Why? Because we cannot traverse back. The single linked list, we can traverse only in the forward direction. So here we need to stop at the second position, second node whose address is 4900. For that purpose, I have taken a k value as a 1, which will monitor the position to which I am moving for, and the temp value start with the start. Now here, when you check the looping, there are two conditions. One's temp of next not equal to null and k less than the position. So there are scenarios where when you were given a invalid position also. At that time, the first condition plays a prominent role. If you have been given an invalid position, then the second condition will always be true, but the first condition becomes false. So when the first condition becomes false, we can conclude that the position what you have given is an invalid position. So here, let me check. So first, initially, what is the temp value? 4800. So what is the k value? K value is 1. So when you check, k is less than position minus 3. That is, here I have to check that 2. Now, temp of next. What is temp of next? 4800 next part. 4900. The condition is true. And 1 less than 2. Yeah, both are true. So I will say temp equal to temp next. Automatically, the new value of the temp is 4900 and k value becomes 2. Now, temp of next 4900 link next part. That is 5000, it is a true, but the condition 2 less than 2, the condition is false. So the target what we want, temp equal to 4900, we got it, we get it. Now, so the temp value is 4900. Now what we need to do? If you observe, the second node should point to the third node and this new node should point to the third node. So these are the two things what we need to achieve. The second node should point to the new node and the new node should point to the third node. So in order to do that, what we need to do first? So among these two, what we didn't do. So if I directly place 4,900, instead of 5,000, if I place directly 6,300 there, I will lose the value of 5,000. So I should not make the second node point to the new node first. I have to make the new node should point to the third node, then the second node should point to the new node. So this is the order of the link changes what we need to do. So if you observe, new node of next equal to temp of next. So new node of next, that is in the place of null, I will observe, so temp of next. So what is the 4,900 next part? 5,000. So I will be getting 5,000, that is a link has been established from the new node to the third node. Then temp of next, what is temp? 4,900. 4,900 next part contains a new node, that is 6,300. So automatically a link has been established from the second node to the third node. So here, if we can observe that, so we have inserted the node at the required position of the linked list. Okay. Then, so this completes the insertion. Now we start with the delete operations. Similar to that of the insert, we have the three different cases to be considered for the delete. So delete from the beginning, delete from the end, and delete at a position. So we start with the delete from the beginning. So here we can consider a node here. Now already, so here before the case, we use it to have memory allocation. The exactly opposite process we need to do. We need to perform deallocation once we remove the node. Now what we do? So here, in order to avoid the errors, especially I can call it as a runtime error, we need to check the underflow condition in case for the deletion. So this is a very important condition we need to check in all the cases. So if check start equal to null, that means that the list is empty. If the list is empty, there are no more nodes to delete. So we say that it is an underflow condition. Now what we need to do? So here the consideration is deletion from the beginning. Now what we need to do? So for example, I want to delete the first node. So if you observe that I want to delete the node with the data value as a 10. Now if I delete it, I should make the second node as a first node. Now what I need to do for that? First, I will make the change in the start. Before making the change in the start, I need to store the start value in another variable. Let me take it as a temp. Why we need to store? You can see by the end of the algorithm. So I will say temp equal to start. That is the temp value is 4,800. Now what is the next step I have done? Start equal to start of next. That is now the new value of the start is 4,900. So now automatically the start will pointing to the next node, which you can see that. Now the thing is that I have to deallocate the memory for the first node, that is the node with the address 4,800. For that purpose, I am say deallocate memory for the temp. So this is a very important thing what we need to do in a dynamic memory allocation. We should allocate, and in the same manner we should deallocate the memory what we have been allocated for the variables or nodes or anything. So we will deallocate the memory for that. Then let us consider the second case, that is the deletion of a node from the end of the list. The same thing, we have checked the underflow condition when the start equal to null. Now what we need to do? So in order to delete the last node, I have to traverse. Where to traverse? Shall I move to the last node? No. I cannot delete a node by staying in the last position. So I have to move to the second last position node. So for that purpose, so I have initialized the temp with the start value, and here you can see an interesting condition. Temp of next not equal to null. What is temp of next? So even though the code looks somewhat interesting, this makes you to stop at the second last node from the end. Okay. Now see that we will check how the value will be. So temp initially will be 4,800. So 4,800. Now let me check 4,800 next part, that is 4,900. 4,900 next part 5,000. Yes, the value it is not equal to null. I will say temp equal to temp next. So temp next value will be 4,900. Next 4,900 next, that is 5,000. 5,000 next part, that is 3,000. Yes, the condition is true. It is not equal to null. Then temp equal to temp of next, that is the value will be 5,000. Now 5,000 next part. What is that? 3,000. 3000 next part, the value is null. So the condition becomes false in this case. So automatically it will ends the loop. Now, if you observe that, what is the temp value finally? That is a 5000. Now, if I want to remove the last node, this node becomes the last node. If you observe that, the node with the address 5000 becomes the last node. But see that before making the value this node as a null, I already said that we have to deallocate the memory. So I am deallocating the memory for the temp of next. So 5000 next part is a 3000. So the memory allocated for this node has been deallocated. Then what I will do finally, temp of next equal to null. That is 5000 linked part contains a value null. So my task has been done. Yeah. So that the last case of the deletion, that is deleting a node from a particular position of the list. So I want to delete any particular node, what I need. So let us observe that I want to delete the third node from the list, what I am doing. So here we need to check for the case. So but here I have not given that. So we need to check the case whether it is an underflow condition or not. Now I want to delete the third node. So temp equal to start. So I am starting, and in order to monitor the position, I am using the variable k, which is initialized to 1. So temp not equal to null and k less than position minus 1. Now let me take what is the initial value of the temp. It's a 4800. What is the value of the k? Initially 1. Now let me check. So temp not equal to null, yes. K less than 1 less than position minus 1, that is a 2. 1 less than 2, yes, true. Temp equal to temp next, that is 4800 next part, which contains the value 4900. K plus 1, k equal to, k becomes 2. Now temp not equal to null, the true, but k less than 2 is false. We will come out of the loop. Now temp is 4900. Now I want to remove the third node. If you observe that whenever I want to remove the third node, I am stopping at the position 2. So 4900. Now what I need to do? So here when I want to remove the third node, the second node should directly point to the fourth node. So this is the thing what I need to do. So in order to make the second node to the point to the fourth node, the address, whatever the address, what is present in this 5000, I should get that into the second node pointer address. So what I am doing for that? So see that temp of next. What is temp? 4900. 4900 next part equal to temp of next. What is the temp? 4900. What is next? 5000. 5000 next 3000. So automatically here I am replacing 5000 with 3000. That is automatically this node will point to the fourth node. Now I want to deallocate the memory for this. So deallocate the memory for temp of next. The temp value is 4900. 4900 next part is 5000. The 5000 value will be deleted from the linked list. So we are achieving deleting a node from the particular position of the list. So with this we have done with all the operations, and we have discussed that. We will finally discuss the differences between the array and the linked list. So here some of the differences has been displayed. First we stored with the definition, and when we go with an array is a collection of homogeneous elements. So whereas here it is a collection of nodes. But when we consider to the data of each and every element, here it is an elementary data value, because it contains only a value. Value may be a multiple things also maybe, but it contains only a value. But if I consider for a node, it contains both the data as well as the address part. So it contains multiple things. That is, it contains the two parts when compared to that of the data. Now here the memory is continuous, whereas here the memory allocation for the nodes is non-continuous. Already we have discussed. Okay, the size, here it is fixed, here it is dynamic. Now when we consider the access, so here we can access the array elements just by using the index. If I want to access the kth element, I can say k minus 1. But here it is not like that. Even if I want to access the fifth element, I will always should start from the first. So if you observe the complexity, here the complexity is big O of 1, whereas here the complexity is big O of n. The insertion and deletion, definitely when we go for an array, definitely array insertion or deletion requires movement of the nodes either towards forward direction or to the backward direction. The metaphor is simply like when we go for a movie in a row, if there are for 10 seats are there, and if 1 to 9 has been occupied, I want to sit in a 5th position. The only thing what I have to do is from the 5th position to the 9th position, I want to make all them to move one step forward or one step forward. so that then only the fifth position will be empty, then only I can sit there. So the array, in the same fashion, we go for an array. Here, the both for the insertion and deletion is having a more time complexity, so we consider it is a slow. But here, just we want to change the references, and the only task what we need to do is we have to move to the particular position. So here the task is moving to the node to the pointer to the particular position of the linked list. The insertion and deletion can be done easily. And the memory usage here it is less because I already it contains only the value, but here it contains more. Memory usage is more because we require some additional pointer for that. And to the last, the structure, here the elements are independent. There is no dependency between one element to another element. But if you observe that here the nodes are linked by the pointers, definitely there is a dependency from one node to another node. And finally, the memory allocation is here for the compile time. Here it is a runtime. It has a static memory allocation. It has a dynamic memory allocation. And so we cannot conclude that the array has a disadvantage or a single linked list is having a more advantage. No, it is not like that. Array and the linked list has both have its own advantages and disadvantages. And choosing among the two, which is the best, depends on the scenario or the situation about how we need. For example, I am using the data where I want to access the data most of the time, where the insertion and deletion operation is less. At the time, the array is the best suited for me. Now, there is a scenario where I have to perform less traversing and I want to perform more insertion and deletion. At the time, the linked list is the best suited. So, choosing of the data structure plays a very prominent role until unless we should get the knowledge on all the existing data structures. So, definitely mastering on this linked list operations makes us to have more applications in the real-time scenarios. Thank you.